Thanks for having me, and it's an honor to be here to talk to you about Artemis III. As Ned spoke earlier, we've got a series of increasingly complex missions coming, and I'll put Artemis III in that broader context. So if we go to the next chart, please. Artemis III, I'll start at the bottom of this chart, is leveraging the capabilities we've already demonstrated on Artemis I, but we'll also further demonstrate with Crew on Artemis II. So that's the Space Launch System rocket, that's the Orion spacecraft, and then the Exploration Ground Systems, including Mobile Launcher 1. In addition to that, on Artemis III, we will add rendezvous proxops and docking capability between Orion and the Human Landing System. It'll be the first Orion to Human Landing System direct rendezvous and docking mission in the lunar orbit. It'll be the first flight of the Starship as our human landing system, and then the first use of our lunar spacesuits provided by our industry partners. In terms of first on that mission, we're going to go and return humans to the moon, specifically in the vicinity of the lunar South Pole. We'll again perform a Orion to Human Landing System direct mission. We'll use a brand new orbit, the orbit that we're going to use starting with Artemis III, and then intend to repeat on missions after that to give us essentially global access to the moon. Is called the Near Rectilinear Halo Orbit. It's an elliptical polar orbit that allows us to have access to pretty much any region on the surface, but we're targeting the lunar South Pole for scientific interest. 4 crew members will transport on the Space Launch System on Orion from Earth to the vicinity of the moon. They'll rendezvous and dock with the Human Landing System. 2 crew members will transfer into the Human Landing System, go down to the surface of the moon, stay there for just under a week, and then come back up. In addition to scientific sample returns, transfer those back into Orion, where for that roughly week-long period, 2 crew members will stay orbiting in Orion in that lunar orbit, and then return back to Earth. All 4 crew members will return back to Earth. So we're conducting a number of scientific studies on the course of that mission. I'll just briefly touch on those in the context of the Artemis III mission, but you'll hear more about those in the workshop later today from a number of experts. So that's the broad strokes of Artemis III. If we go to the next chart, we heard the science objectives loud and clear from the science community. These are your objectives, the scientific community's objectives. And you'll start to see on the next page or two how we are starting to check off and acquire data using the Moon to Mars infrastructure and spacecraft and rocket and lander capabilities that Ned highlighted earlier, and Nikki highlighted the partnership. So as we understand things like planetary processes and the origin of volatiles, and investigate and mitigate risks associated with the Artemis missions, we are partnering with the Science Mission Directorate to fly experiments or conduct geology field campaigns of interest to the community as part of the broader interest that is then ingested and then planned to utilize these capabilities that were talked earlier. On the next chart, as far as one of the key sets of objectives, I'm proud to partner with Dr. Brett Denevi and the Artemis III geology team, and Dr. Noah Petro. You'll hear from Noah later today on how we're working together to accomplish both deployment of scientific instruments that I'll talk on the next page, but also conduct a geology field campaign when we get our 2 astronauts down to the surface. And our goal is to make the geology team members a part of the overall science team, a part of the overall Artemis mission. And we've already started a number of engagements and working together with them, knowledge sharing of some of our constraints and limitations, but also understanding what their objectives are and how we can support each other, and really understand how we can apply the suits walking from a lander, and what the video and communications and sampling constraints are, as well as hazard avoidance on the surface of the moon, so that we can keep our astronauts safe while we do gather scientific evidence tracing back to those objectives earlier. So as we're doing very detailed things such as traverse planning at a specific landing site, all those things are factored in. And this will be the first time that this particular team has done it, and it'll be the first time that we've done it with these capabilities, the Starship human landing system and the suits and the scientific instruments that we have planned on these missions. So we're excited to partner with our friends in the Science Mission Directorate. We're excited to partner with the Artemis III geology team and accomplish a common set of goals per the pillars that were talked earlier by Ned and Nikki. Next chart, please. In terms of the science instruments, you'll hear more about these later today from Dr. Noah Petro, but we do have 3 science instruments that will be pre-positioned in lunar orbit. We'll load these on the human landing system before it launches and is sent outbound to the moon. And then when our astronauts arrive in the lunar orbit on Orion and rendezvous and dock and then take the lander down the surface, those instruments will already be in the human landing system. So we've got LEMS, LEAF, and LDA, and I won't steal Noah's thunder. I'll let him describe the specifics, but we are already having initial conversations on how to most efficiently utilize the astronauts' time to deploy the instruments within their constraints, and maybe in some cases get a 2-for-1, where we're conducting a geologic field campaign in addition to deploying these instruments, and where we can find opportunities to accomplish multiple goals at once. And then also as part of that, you'll see very clearly that these scientific instruments trace back to those goals earlier. LEAF, LEMS, and LDA help us buy down and understand a number of the scientific goals and objectives. And these are already part of the Artemis III mission. They were announced earlier this spring and were competitively selected by the Science Mission Directorate. And we're proud to provide not only the transportation and crew time and just overall ability to deploy these, but also just to be a part of the broader team here. On the next chart, Ned showed progress across the Artemis portfolio. If you look specifically at Artemis III, we've already got quite a bit of hardware either in production or it's already completed. The booster segments used for the Space Launch System are already cast and complete. The upper stage used to perform the translunar injection is already complete. It's already at the Delta Ops Center in Florida. The Orion spacecraft, the crew module, primary structure is built, and the secondary structure and outfitting is already in progress. The European service module, I was over in Bremen late last year. That is nearing completion. We're just waiting on a few components before that is shipped to the United States this summer. The core stage is well into production. The engines are ready. And then in parallel with that is we continue to build up the rocket, the spacecraft. We're going through the development program associated with the human landing system and the lunar spacesuits. You can see on the bottom there in that white box, the Starship test campaign is ongoing in parallel with production of the spacecraft and the rocket. And our partners, our commercial partners, have already completed their orbital flight test, which successfully delivered Starship to Earth orbit. We've got a couple of significant milestones coming up in the spring of next year, which is a long duration test flight where we characterize the cryogenic boil-off rate, and then we'll conduct a propellant transfer mission between 2 Starship vehicles to aggregate propellant. before we send up the human landing system and then fuel it up and send it to the moon. There are updates ongoing at the Kennedy Space Center to prepare for Starship launches from the 39A pad. And then we've got an uncrewed demonstration flight of the human lander before we perform the full up crewed test flight. And in parallel with that, we'll have the scientific instruments developed through our science partners, and then they'll be delivered to the launch site and integrated to the lander, as I mentioned earlier. So a lot of activities going on in parallel. The suit testing is ongoing. And you see here the blue boxes are kind of new content. The red boxes or the maroon boxes are content that's kind of the either the second or the third iteration based on whether we did it on Artemis 1 or 2 previously. And this again shows that we are increasing our capabilities as we move forward. Next chart, please. Here you can see some baby photos of the flight hardware. The rocket is coming together well. The spacecraft is coming together well. There's the European service module in the upper right. And then on the next chart, you can see the development activities for the suit and the lander. Next chart, please. Here you see the development activities for the suit and the lander. They're not quite to the critical design review level. We'll get there either this fall or next year for the suits and the lander. We're past the preliminary design review level, but there are a number of development iterations going on here. So teams are working hard. We've got our astronauts in the field. They're providing feedback. Our engineers are working with our commercial and industry partners to get all this ready. And again, that's kind of the current snapshot of Artemis 3. And with that, I'll hand it back to you, Jake.